How does one characterize the speech intelligibility? Let us consider the room with the speaker and the receiver as a sound filter with a speech signal coming in.
This is a test for speech intelligibility assessment.
And this signal goes through a filter consisting with reverberation.
This is a test for speech intelligibility assessment.
But there might also be background noise superimposed to this signal.
This is a test for speech intelligibility assessment.
So how to characterize this speech intelligibility? First kind of methods are the subjective methods, which consists in playing words and asking subjects to recognize whether or not they recognize the words. These tests are quite time-consuming. They need many subjects to be valid, so it's difficult to organize. So we usually prefer the objective measurements, which can be, for example, the speech transmission index, which is the most widely used index, but there are many others index, like, for example, the articulation loss of consonants. Many other indices exist, which are summarized here on this common intelligibility scale. So how to measure the STI? Let us consider the signal envelope, the speech signal envelope. This signal goes through a filter, which is reverberation, and the reverberation will tend to reduce the modulation index, the amplitude of modulation of these signals, these modulation which represent the phoneme flow. And there also is background noise, which will set a kind of floor value in this signal. So in order to measure that, the method used by STI is to send a noise signal, this noise being an octave band noise, octave from 125 Hertz up to 8 kilohertz. And this noise here is modulated with a frequency from 0.6 to 12 Hertz. And this modulation, again, represents the phoneme flow. It goes through the filter, and then the output of this filter is that the modulation index is reduced. Here M2 is smaller than M1. The ratio M2 over M1 depends on the octave band considered and on the frequency of modulation. So there's a table of value. From this table, one single index is computed. This single value obtained has to be above 0.5 in order to have fair intelligibility. It can also be derived from the impulse response. Measurement tools exist, sound level meters and PC-based software in order to achieve this measurement method. STI is not perfect. We will see in the next question the limitations. But let us remember that reverberation tends to decrease intelligibility when it is high. Like, for example, in a cathedral, then very high reverberation time will impair speech intelligibility. Also, background noise tends to decrease intelligibility, especially when it's above, the signal-to-noise ratio is above 15 dB. When it's less than 15 dB, it does not affect intelligibility. When it is more than 15 dB, then we have problems with intelligibility.